Page 14 of Applications of Calculus. We are going to start working on areas under curves. Okay, so write the integral expression to calculate the area under the curve f of x between the lines x equals a and x equals b. Remember that we do the integral sign and the limits are a and b, and the left limit goes in the bottom and the right limit goes on top. The f of x defines the curve which goes across the top here. F of x is this curve here. A is the left boundary, b is the right boundary, and of course the bottom boundary is the x-axis. We finish up the notation by putting dx at the end. Remember that basically when we do this integral, f of x is the height of each little rectangle, and d of x is actually the width of each one of these little rectangles. So it's kind of like length times width inside the integral sign. Just like when we did the summations, we had length times width inside the summations. It's okay if you don't understand it. Just think of dx as kind of like a period. Okay. Find area of each of the regions described below by using a geometric argument and integration. Okay, so first of all, I'm going to draw the x-axis and the y-axis in red. And then I'm going to use blue to draw the function. So y equals 5 is a horizontal line at height 5. X equals -6 is the left boundary. X equals 0 is the right boundary. So basically, the bottom boundary, of course, is the x-axis. So basically, we're talking about a rectangle here. The rectangle height is 5, and the width is 6, right? So 5 times 6 is 30. So the geometric argument would be just finding the area of a rectangle. 5 times 6 equals 30. Using integration, we would put integration sign from -6 to 0. -6 goes in the bottom, 0 goes in the top. The f of x function, of course, is this function here, which bounds the top. The equation for this function is y equals 5, so we just put 5 here. And then, of course, dx to finish it off. So if we wanted to calculate with an integral, first thing we're going to do is we're going to find the integral of 5. It's 5x. And then we write the bracket showing that we're about to substitute in 0 and -6. First we put in 0, and then we subtract, putting in -6. That would be 0 plus 30, which is equal to 30. So we still get the same result by doing the integral. We got the same result as doing the length times width, 5 times 6. Next one, again, we're going to draw a picture. And I'm going to draw the x and y axis first. The function is -3x, which of course is a straight line. It's a straight line which is diagonal and goes down, right? Because -3 is a negative slope. And it is bounded by the diagonal line and the x-axis on the bottom, and x equals -3 on the side. -3, and x equals 0, which is where y equals -3x intersects the x and the y-axis. And so it's a triangle, right? The question is, how tall is this triangle? If I want to know what this point is, I know that the x coordinate is -3. The y coordinate I can find by plugging it into the equation -3x. So -3 times -3 is +9. So its height +9. So the dimensions of this triangle, the x dimension is obviously 3 wide, and the y dimension is apparently 9 wide. So we could use the 1/2 base times height formula. So 1/2 times 3 times 9 is equal to 27 divided by 2, which is 13.5. So the area is 13.5. Now we're going to use integration to do the same thing. So we're going to integrate between the left boundary and the right boundary. So it would be between -3 on the bottom and 0 on top. The function is -3x. And then, of course, we put dx at the end to finish it off. And then if we want to take the integral of that, negative 3x, the integral would be negative 3x squared over 2, right? And then bracket negative 3 to 0, which means we're about to put in the 0 and negative 3. The 0 goes on the right, so it would be negative 3, 0 squared over 2, minus, and then we're going to put negative 3 in for x. Okay, and then we just simplify now. 0 minus, let's see, negative 3 times negative 3 squared. So that would be negative 3 times negative 3 times negative 3, which is negative 27 over 2. So I could cancel out those negative signs. So the answer is 27 over 2, which is 13.5. And that's what we got when we did 1/2 base times height also. Okay, so it's fine. 2, find the exact value of the area of the region bounded by, let's draw another picture, x-axis, y-axis, y equals x squared. Oh, that's a parabola that has its vertex at 0, 0. The x-axis, so right here, and x equals 1. Let's say it's right here. Okay, so basically it would be this shape here, right? We are going to do this by integration because we don't have any formulas to calculate the area under a parabola. So I'm going to do integral from this boundary, which is obviously 0, to this boundary, which is 1. And then I put the function in there, which is x squared. That's the top boundary. And then we just put, and then the bottom boundary, of course, is the x-axis. And then we put dx. We're done, right? Now let's just do the integral. So the integral of x squared is x cubed over 3, bracket 0 to 1. And then we're going to plug in the 1 and the 0. 1 cubed over 3 minus 0 cubed over 3 equals 1/3 minus 0 equals 1/3. So the answer is 1/3. All right. Next one. Y equals x cubed, the x-axis, x equals 1 and x equals 4. So we're just going to draw a picture again. If you don't know what these look like, go ahead and graph it on the calculator first to give yourself an idea. If you remember, x cubed is a cubic, so it looks kind of like that. We're talking about the right side of it, not the left side of it, but we don't know that yet, so let's go ahead and draw the whole thing. We are going to do the area bounded by x cubed on top, x-axis on the bottom, and x equals 1 and 4 on the sides. So that would be 1 and 4, not to scale. So basically this kind of trapezoidal-like area. It's straight on the side, straight on the bottom, and curved on top. How are we going to do this one? We're going to integrate from 1 through 4. So we put 1 and 4, 1 on the bottom, 4 on top. We're going to put x cubed, the function for the top, and then dx. So that'll be the integral of x cubed is x to the 4th over 4. And then bracket 4 and 1. And then we substitute in the 4, we substitute in the 1, so we get 4 to the 4th divided by 4 minus 1 to the 4th divided by 4. So that would be equal to 4 to the 4th is like 16 squared. Oh, actually, let's simplify a little bit. 4 to the 4th would be 4 times 4 times 4 times 4. One of these 4's would cancel out with the 4 on the bottom. That would make it 4 cubed. 4 cubed, it turns out, is 64. I just have that one memorized. Minus 1 to the 4th is 1, so minus 1/4. So the answer is 63.75. Okay. E. The x-axis and the part of y equals 6 plus x minus x squared above the y-axis. Okay, so this one, let's see. I think it's easier if we graph this, so I'm going to graph it on the calculator and then we'll proceed, okay? I know this is a parabola. I know it opens down, but I don't know exactly where the x-intercepts are because they didn't give it to me in factored form. So on an exam where it's paper 2, you would find the x-intercepts by using the calculator. So why don't we try practicing that? So we're going to graph it. So I adjusted it so that it was standard zoom. I can already see that it intersects at -2 and 3. If I wanted to make sure, I could do second calc 0 to see precisely, okay? But so let's say it intersects at -2 and 3, and I saw that using just looking at the graph. So I'm just going to draw my picture here. So -2 and 3 are the x-intercepts, and then it goes up like that, right? Something like that. Yuck. Kind of like that. Okay, and so we're going to find this area. How are we going to do that? We're going to do the integral from -2 to 3, -2 on the bottom, 3 on the top, and then I'm going to put the function inside the integral, and then I just finished off with dx. That's it. So let me do this integral. So the integral of 6 is 6x, the integral of x is x squared over 2, and the integral of -x squared is -x cubed over 3, bracket -2 to 3. Now I just plug in the 3 and the 2, 3 and the -2, I plug in the 3, I plug in the -2, and then I just subtract the results. So 6 times 3 plus 3 squared over 2 minus 3 cubed over 3, put in parentheses, minus, and then I'm going to put 6 times -2 plus -2 squared over 2 minus -2 cubed over 3. Okay, so let's try to simplify that. All right, I'm just going to use a red pen too. This would be 18. This would be 9 halves, which would be 4.5. This would be 3 cubed over 3, which would be 3 times 3 times 3 divided by 3. It would be 3 times 3, so minus 9. Over here we have minus -12. 6 times -2 is -12. -2 squared, which would be positive 4, divided by 2 is positive 2. And then the last one is -2 cubed, which would be -8. -2 times itself 3 times -8. -8 divided by 3 plus, minus -8 divided by 3. So it would be plus 8 over 3. Okay. And I'm just going to use the calculator to add some of these things up. Hold on a second. Okay, I just entered everything into the calculator and I hit enter and I get 20.833. If I'd liked it in a fraction, I could put math and then I just hit enter here and the fraction would be 125 over 6 or 20.83 repeating. Okay, so that was E. Let's do G. So G, we know what 1 over x looks like. We don't need to graph that. Remember 1 over x is the rational function. Whoop. We had that in chapter 2. All right, and then, so 1 over x, x-axis, the bottom, x equals 1 right there, x equals 4 right there. So it's like this area right here. How do we do that with an integral? We do an integral from 1 through 4. We put the top function, which is 1 over x, inside, and then we just finish off with dx. What is the integral of 1 over x? We just look in the formula booklet. It says natural log of x, right? That's an easy integral. Bracket 1, 4, and then we plug in natural log of 4 minus natural log of 1. We don't expect you to know what natural log of 4 is without using that calculator. We can just leave the expression natural log of 4. But what is natural log of 1? We should know that. Natural log of 1 is 0. Just like e to the 0 is 1, natural log of 1 is 0 because they're inverse functions. So the answer is natural log of 4, and we're done. Okay, and that's it for this page.